All right, I'm starting to make my video on the practice exam you guys took in AP Stats. You will get the second part on Friday. We started with number 10. A popular computer card game keeps track of the number of games won on the computer. The cards are shuffled before each game. So the outcome of the game is independent from one game to the next and is based on the skill of the player. Let X equal or represent the number of games that have been won out of 100 games. Under which of the following situations would X be a binomial random variable? Well, the first thing we need to remember is what does it mean to be a binomial random variable? And that is, if you took Mr. Jan's class, that would be bins. If you took my class, it would be biffs. It's the same thing though. The first one is binomial. Okay, B stands for binomial. B is equal to, is there a success, failure? Two outcomes there has to be. Independent, you just have to state, like if it's a free response exam, you'd say, hey, the probability of one person drawing out a card does not affect the other one because the computer's doing it, or however. You just need to state it in words. N, F. I said F because we're dealing with the fixed number of trials. In the book, it is N, though, I believe. So the number of trials are fixed. And then S is the probability of success has to remain the same for each trial. Let's go through it now. All games were played by the same player whose skill improved over the course of 100 games. It cannot be A, and the reason it cannot be A is because their skill improved each time. That would violate our S portion. A group of 5 players of different skill levels, again, our S portion, we're allowed to play 20 games in a row. There's a fixed number there, which is good, but still it violates. C, a group of players with different skill levels were allowed to play until they had lost 3 games, and this resulted in 100 games played. Again, here, this is a little bit more geometric, as well as the different skills, though, and then we do have the fixed trials, kind of. It's not correct, though, for a binomial. It is not technically geometric either, though. 2 players of equal skill level, okay, we like that, played 1 game a day for 50 days, fixed trial, and their skill level did not change from day to day. Is there still a success failure? Yes, they either win or they don't, okay? 2 players of different skill levels, bad. We're allowed to play, allowed using 1 player to continue until a game was lost. That's wait time there. E is wrong. The final answer is D. Hopefully that made sense to you. Moving on. Number 14 was the next question. Which of the following statements must be true about the data sets A and B in the histogram above? The mean data set A is equal to the mean data set B. We don't know that. We just have a histogram. And we know in this histogram, for example, in this first bar, there are 8 values that are between 10 and 20. In this bar, there's 1 value between 10 and 20. We don't know what the value is, though. So there's no way we can say if the means are equal. We do know that the means will probably be around here for both of them. How do we know that? Because they're both exactly symmetric, so we can guess the mean will be somewhere in the 30 to 40 range. The median of the data set A is equal to the median of the data set B. Again, for the same reason we can't choose A, we can't choose B. The range of the data set A is equal to the range of the data set B. Again, we have no way of knowing what this maximum value in this bin is. Okay? Same for this bin here. The standard deviation of data set A is less than the standard deviation of data set B, and E is greater than. Okay, well now we need to think about what is the definition of standard deviation. That's the average distance from the mean. We know the mean is going to be in the center here. How do we know that? It's extremely symmetric. The median will also be in the center there. But we care about the mean right now. The standard deviation now is the average distance the observations are from the mean. Well, data set A is going to have a bigger standard deviation. Why? Because the observations, there's many more observations that are further from the mean on data set A than there are from data set B. As a result, that average, those observations that are far away from my mean, are going to pull that average distance up. That makes E the correct answer. The next question you guys had was number 15. I think this is one of the hardest ones on the test. Once you get it though, you're going to say, oh, that makes sense. Okay, we have two different things going on. We have a bag that has 10 tags. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also have another bag that has 20 through 27. All the way to 27. Oopsie. Expected value. Expected value in your calculator or using hand is the sum of your observations times your probability of that observation. Well, let's talk about the probability then. The probability for each value here is 1/10, straight across. The probability for here is 1/8, straight across. It says, what is the expected value of the sum of both of the bags together? So let me get a new page for us, if I know how to do that. I don't think I can add a new page, so I need to go to the end. That's fine. We're still in number 15. I need to find the expected value of x and just add it to the expected value of y. I can individually do that by hand by doing that sum of xi times b of xi, or yi, excuse me, times b of yi. That's really going to take a lot of time though. So what I'm going to do instead is I'm going to put my x distribution in my L1, okay, and the probability of x in L2. And then I'm going to run a 1 variable stats on L1 comma L2. Okay, if you have the newer technology, you'll see it. It will say L1, and then I believe this is your frequency. Your X bar here is your average. That's your expected value, and there you get 5.5. For the Y distribution, you do the same thing. Okay, so this would go in L1, this would go in L2. Run your 1 variable stats, and you get your X bar, which is your expected value. And that's equal to 23.5. Then to do the expected value of X plus the expected value of Y, you're going to take 5.5 plus 23.5. When you add that up, you get, what did I say, 23 and 5, you get 29E. All right, number 16. A pollster is interested in comparing the proportions of women and men in a particular town who are in favor of a ban on fireworks within town borders. The pollster plans to test the hypothesis that the proportion of women in favor of the ban is different from the proportion of men in favor of the ban. There are 4,673 women and 4,502 men who live in the town. This is our capital N. Capital N for men. Capital N, whoopsie, sorry about that, for women. Give me a second. I'm going to change my pen and my color. From a simple random sample of 40 women in the town. That's my little n. Okay. The pollster finds that, shoot, I can't see, 38 of them favor the ban. From an independent sample of 50 men in the town, the pollster finds that 27 of them favor the ban. Which of the following samples must be true? A, because the samples are from a normal population, it doesn't say anything about the normal population. Because the size of each sample is greater than 30. Yes, they are greater than 30. However, this is for means. We're dealing with proportions. Because the number of people who favor the ban is greater than 10 in both groups, a true proportion z-test would be valid. This isn't true. What needs to be greater than 10 is your n times p hat. Has to be greater than 10. And n times 1 minus p hat. Greater than or equal to 10. This is the normal condition. This allows us to use the z-chart. Because the relative sizes of the population and samples, so the relative sizes of the population and sample, what that's saying is that's referring to our condition 10n, the sample, compared to capital N, our population. If you check that, that checks out. 10 times, what do we have? 40 is less than 4,502, and 10 times 50 is less than what? Ooh, I'm sorry, that is not true there then, okay? 10 times 50 violates that, so D is not correct either. So a true proportion z-test would not be valid. I believe I marked that one wrong. I think I put D on the test, and I apologize if I did that. A true proportion z-test would not be valid because that violates it right there. And two more. Employees at a large company can earn monthly bonuses. The distribution of a monthly bonus earned by all employees has a mean of 2.3, a standard deviation of 1.3. Let Z represent the standard normal if distribution. If X bar represents the mean number of bonuses last year for a random sample of 40 employees, which of the following calculations will give the approximate probability if X bar is less than 2? We would just do Z is less than our observation. Okay, observation is 2 minus our mean divided by our standard deviation, which needs to be divided by the square root of 40. As a result, our answer is A. Number 18, the p-value for a one-sided test is 0.10. If it's two-sided, it's symmetric. This is 0.10 as well. B is my final answer. And 13 minutes later, I am done. Let me know if you have more questions.